Let's talk about graphing motion. So, when we have something like this, which is a position versus time graph, and of course, sometimes you'll see displacement versus time, where displacement is on the y axis, basically the same thing as a position versus time graph. Or you might even see distance versus time. Sometimes it's labeled like that. But these are all the same things, right? We're graphing the object's position as it changes with time. So, when we have a graph of anything, how do we find the slope? If you remember back from math class, slope is going to be the rise over the run. So if we look at this graph right here, if we're going to graph rise over run, we can see that the rise is going to be the change in position and the run is the change in time, or just time that we're, recording this change in position. That looks kind of familiar, right? It should, because change in position over time or displacement over time is velocity. Okay, so this is a key part right here. You need to know how to interpret these graphs right here. So we know that the slope of a displacement versus time graph is velocity. Now let's look at a graph that's a little bit more complicated. So if we see a graph like this, all right, I know it looks a little bit crazy, but let's really think about what's happening here, okay? So we can see that number one, that we're graphing position versus time. So position as it changes with time. So the object here is starting at the origin. So that means we're starting at x equals 0. Now, again, we know that the slope of a position versus time graph is velocity. So we can see that as this object, or as the time goes on, the object is now going in the positive direction because it's going toward that x equals 60, positive 60 meters. And because it's going in the positive direction, it has a positive velocity, a positive slope. Okay, we can even find that slope too if we want to find the velocity. The rise is 60, so 60 over the run, which is 10, so we can see that the velocity is a positive 6 meters per second. So we have a constant slope, which means we have a constant positive velocity, which means we're moving to the right. We'll call that the positive direction at 6 meters per second. Now at 10 seconds, we can see here that we have a flat part of this graph, right? From 10 to 15 seconds. So what that tells us, remember, slope is velocity. That tells us we have a velocity of 0 because the slope is 0. So we're staying put at 60 meters for 5 seconds. So the object is stationary at x equals 60 meters for 5 seconds. After that, at 15 seconds, it looks like we're going to turn around and we're going to head back toward the origin. Okay, do you guys see how we're at 60 meters, but then we're going to decrease our position? So meaning we're turning around, we're heading back toward the origin. We have a negative slope from 15 seconds to 40 seconds, which means we have a negative velocity, which means we are headed in the negative direction, which in this case is to the left, because we said the right was positive. So we're going to the left from 15 to 40 seconds. We can even find our velocity there. So the rise in this case is going to be 60 plus 40, which is 100, divided by the run, which is, I can't do math in my head right now. 40 minus 15, which is 25. So 100 divided by 25 is 4. So this is going to be a velocity of 4 seconds, but headed to the left. So really a negative velocity. So we have a constant negative velocity moving to the left at 4 meters per second. So we're moving to the left at 4 meters per second. At that point right there where we cross through the x-axis, that means we're crossing through the origin, right? Because we know that the x-axis is x equals 0. So the object passes through the origin there. And then at 40 seconds, it looks like that negative velocity then becomes a positive velocity. So that means that, remember, sign of velocity is just the direction that we're moving. So from 15 to 40 seconds, we're going to the left, and then at 40 seconds, the object turns around, okay? And then we're moving back toward the origin to the right because we have a positive velocity from 40 to 55 seconds. And again, we can find that positive velocity just finding the slope. So the rise in this case is 40, and the run is 15. So 40 divided by 15 is 2.67. Sorry, I got in the way right there. So we have a constant positive velocity moving to the right at 2.7 meters per second, and then we end there at the origin. Okay, so the object ends at the origin. So that is how you're going to interpret these graphs like this. Now, the main takeaway here is that I want you to remember how to find the slope, the rise over the run, and that when we have a displacement versus time graph, or a position versus time graph, same thing, the slope is going to be velocity. Okay, so think about that. Now, it gets a little bit more complicated, and you guys will be using this next thing that I'm going to teach you when you do the match that graph simulation this week. So when you have a graph like this, so again, this is a position versus time graph, but this is a little bit more complicated because it's not a constant slope. All right. But what we can do here is we can we just want to interpret what's happening to the slope. So remember, on a position versus time graph, the slope is velocity. So whatever is happening to the slope is happening to velocity. So I want you to almost take a pencil, okay? I have one, here's my Apple pencil right here. Take a pencil, put it up to your screen, all right? And see what's happening with that slope. So we can see at the beginning, that slope is 0. Do you see that? If you put your pencil up to it, there's no slope at the very beginning, right? This is called a tangent line. When you kind of put this up like this and you kind of see what's happening to the slope, we're seeing what's happening to the tangent line to the slope. So slope starts at 0, which means our velocity starts at 0. And then we're getting more and more and more positive. Do you see that? Okay, so what this means is the slope is getting more and more and more positive and steeper and steeper and steeper, which means that our velocity starts at 0 and then it gets higher and higher and higher in the positive direction. All right, so if we were to graph velocity, it would look like this. Okay, velocity starts at 0, it then gets higher and higher and higher, and it gets more and more and more positive, right? So this is what you're going to do with the match that graph activity. You're actually going to match the position versus time graph with the corresponding velocity versus time graph. Here's a little description of what's happening. So the object starts at a velocity of 0, and as time goes on, the slope is increasing and positive, therefore velocity is increasing and positive. All right, let's try one more with this. So here is another position versus time graph. Now here I want you to, again, take your pencil. I want you to match it up to that actual graph like that. And you can see that the slope here is constant, which means that the velocity is constant, okay? So we have a constant velocity, but is that positive or negative? Is the slope positive or negative? The slope here is negative, right? It's going down as you go to the left. So what this tells us is that the velocity is constant and negative, all right? So the way that you draw this, constant velocity is just going to be a flat line, and it's negative, so you want to draw it below the x-axis. So this is what it would look like this, okay? So that is the kind of graph that you would match to this position versus time graph. So again, the slope is constant. Oh my goodness gracious. So the slope is constant and negative, and therefore velocity is constant and negative. Now, when you guys start that match that graph activity, I am going to have a little video of how you actually do the activity. So don't worry too much about this right now. You'll get plenty more practice later.